right? Okay, then shall we start? Right, that as I told you that as we did in the chemistry section, Pute, right, we will try to remind all the subject content regarding all these questions, right? We will start with the first one, right? Look at that one. Which of the following is a vector quantity? Which of the following is a vector quantity, right? So when you read the question, right, when you read the question, right, the question should come to your mind. What are vector quantities, right? uh, we learn about two types of quantities, Pute. Yes, if you can remember, yes, scalar quantities and vector quantities. Scalar quantities and vector quantities. Scalar and vector, right? What are scalar quantities, Pute? Can you remember? Scalar quantities. Yes, scalar quantities means they have a magnitude, right? They have a magnitude, but when we consider the scalar, right, no direction, right? For scalar quantities, they have a magnitude, but no direction for vector quantities. Sorry, scalar quantities, right? Give me 1 second, Pute. Right? So for scalar quantities, only there's a magnitude but no direction, right? But when we consider vector quantities, they have the magnitude, right? They have the magnitude and also they have a direction, right? They have both the magnitude and the direction, right? So here, from the given four answers, right? What is the answer, Pute, that have the both the magnitude and the direction? Yes, weight, time, speed and distance. Weight, time, speed and distance, right? So when we consider time, no direction, right? Speed means what, Pute? Speed means the rate of change of distance, right? The rate of change of distance, right? So there is no direction for speed, right? So it is also a scalar quantity. Then what is distance? How we explain that term, right? Distance, that is the length of the path, right? Length of the path that an object travel, right? Length means Again, it is a scalar quantity. No direction for the distance, right? So what is the scalar one? Sorry, vector one here? That is the weight, right? Weight means the attraction force towards the ground, right? So we get we calculate the weight by using this one. W equals mg, weight equals mass into gravitational acceleration, right? I am telling these things to remind you all the things, right? Then what is mass, Pute? How we explain that one? Mass, that means the amount of matter, right? Amount of matter. That is how we define mass, right? So here, the weight is the vector quantity, right? When we consider the speed, right? When the word or the quantity that related with the speed, that is velocity. Velocity means the rate of change of displacement, right? Displacement. Then it is a vector quantity, right? It is a vector quantity, right? The next question can be made like this. Instead of weight, they can give mass, right? And time. Instead of speed, they can give velocity. Then what is the vector one? It should be velocity, right? When we consider distance and the regarding one, displacement. Again, the displacement is a vector quantity, right? Displacement is a vector quantity. Like that, by considering the four answers, right? Remind all the things, right? Remind all the things that connected with these four answers, right? Look at the second one, Pute. What is the unit of the moment of force? Moment of force, right? What do you mean by moment of force? How we can calculate the moment? Yes, moment, it is force into the perpendicular distance. Force means we measure the force in newtons and the distance from meters. So what is the unit, Pute? Newton meters. Newton meters. Right? Third answer. Right? What is first one here? Joules per second. Joules per second means watt. That we measure the power. Right? And what is the second one? This is first one. Second one, what is it? kg ms minus 2. What is this one, Pute? Right? How we define this one? Right? This is how we get the unit Newton, right? By considering this equation, F equals ma, right? By considering this equation, right, we get the unit Newton to measure the force, right? How we explain there? The force that we have to apply, right, to give 1 meters per square second acceleration, 1 meters per square second acceleration for an object with a mass of 1 kilogram, right? The force that we have to apply for an object with 1 kilogram to give an acceleration of 1 meters per square second is 1 Newton, right? So kg ms minus 2 means Pute Newton, right? Newton. And what is the fourth? The third one is this one, right? Then what is the fourth one, Pute? Right? Newtons per square meters. Newtons per square meters. What is this one? Newtons per square meters. We get this one when we calculate the pressure. Pressure means the force divided by the area. Force divided by the area. So the force we measure using newtons and the area by square meters. So newtons per square meters. Newtons per square meters. Right? Newtons per square meters. Right? We use the unit as Pascal, as the owner to the scientist Pascal. Right? So 1 Newton meters per 1 meters per 1 square meters per Newton is 1 Pascal, right? So these ones also you have to remember, right? For the next one, they can give a question by using this, right? So all the equations in the syllabus you have to remember, and the units, right? If they are units like this one, right? This is the SI unit, watt, and this is the fundamental one, right? Here also what is the SI unit and this is the fundamental one, right? Like that you have to remember these things also, right? Then we will move to the third one. Which of the following energy transformation take place in a bicycle dynamo? Right, in a bicycle dynamo, what happens? The magnet is rotating inside the coil, right? So the kinetic energy is there because the magnet is rotating, right? But here there is no kinetic energy, right? We know mechanical energy divided into two as kinetic and potential energy, right? So as a whole, here we have to consider mechanical energy. So in the bicycle dynamo, mechanical energy converts to electrical energy, right? If you are given in the question, the light in the bulb in the bicycle lights up or something like that, that means that electrical energy again converts to light energy, right? So according to the question that you are given, you have to select the energy transformation, right? Look at the fourth one, Pute. In which of the following instances does a couple of forces act, right? And this is a place that you mix up the couple of forces and the moment, right? You have to identify what is moment and what is the what are the places or the instances that apply the couple of forces, right? We will check the answers. When a door is opened by pushing, right? When a door is opened by pushing, right? Opened by pushing, we apply a force, right? In this, like this, right? Fourth one. This is the door, right? Right? There's a point that we apply something like the handle, and this is where the door is fixed to the wall, right? So when we open or close the door, right, the door is rotating around this axis, right? This is the axis of rotation, and this is the place where we apply the force, right? So we calculate the moment, right? This is where we apply the force, right? We calculate the moment by getting the product of force and this perpendicular distance, right? So open or closing a door, right? And open or closing a window, right? So in those instances, the moment is applied, right? Moment is applied. Look at the second one. When a nail is unscrewed by a screwdriver, what is screwdriver? It is something like this, right? Screwdriver. Here, we have to rotate it. When we rotate the screwdriver, when we screw or unscrew in this way, right? What happens there is we apply the force in this way and this way, right? When we rotate the screwdriver, right? So here there are two forces, couple of forces, right? The two forces are equal in magnitude and opposite in direction, and there's a distance between the two forces, right? So what is the answer is the second one, using the screwdriver, right? Then what is the spanner, Pute? Can you remember it? The spanner is like this one, right? You know those things, right? In this way, right? When we use the spanner, right? When we use the spanner, it is not a couple of force. Again, it's a moment, right? When we apply a force from a distant place, then the perpendicular distance is more, right? Then very easily we can remove the nut, right? The spanner is the moment and the screwdriver is the couple of forces, right? Then look at the, we will go to the third one. When the rope is pulled in opposite directions by two groups in a competition of pulling ropes, what is that? They are the forces applying to the two directions, but the two forces are to the opposite direction, but they are on the same line of action, collinear forces to the opposite direction, right? Separately, we discuss all these things, how we can get the resultant force, right? So, they are collinear forces to the opposite directions, right? Then look at the fourth one. When two persons are pushing a box in the same direction which is kept on the floor, right? Two persons. There's a box, right? Two persons, right? They apply the force to the same direction in this way, right? One force is here and the other one also. There are two parallel forces, Pute, right? Two parallel forces, right? That is not couple of forces, right? So the answer should be the second one, right? Then look at the fifth. The SI unit of force in fundamental units is, that is what we discussed. SI unit of force in fundamental units, right? So we get this by question fifth one, right? By using this equation, as I told you, right? The force that we have to apply for an object with 1 kilogram to give an acceleration of 1 meters per square second, right? Then kg ms minus 2 kilograms meters per square second, right? This one we use as the SI unit as Newton, right? So what is the answer, Pute? First one, right? First one. Then look at the question number 6. Question number 6, right? If an object is to stay in equilibrium under three forces, right? Here they have not asked whether we have to find the correct answer or the incorrect one, but when we consider the four answers, right, three are correct, and then that means we have to select the false one, right? We will see. If an object is to stay in equilibrium under three forces, Pute, right? Three forces. The resultant force of two forces should be in the same direction that of the remaining force, right? We will take one example for this one, right? Equilibrium under three forces, no, right? Then we know what are the factors it should fulfill to keep an object under three forces, right? And they have not mentioned whether the three forces are parallel to each other or not, right? That one also there, right? If the three forces are parallel to each other like this, right? The weight comes here, and when we mention as T1 and T2, right? These are the three forces, right? This is three forces, the parallel three forces, right? And when we take this one, Pute, when we hang a photo frame like this, right? So this is the weight here, and this is T1 and T2, right? So according to the first sentence, first answer, the resultant force of two forces should be in the same direction as that of the remaining force. When we take this one, Pute, the resultant force of two forces should be in the same direction as the third force. Not to the same direction. The resultant force of two forces should be to the opposite direction of the third one, right? Here also same. Not the sum of these two, resultant of these two should be opposite to the third force, right? So the first sentence is wrong. Look at the second one. The resultant force of the three forces should be 0. Yes, there may be no resultant force. As a whole, when we consider no resultant force, that is why they are in the equilibrium position, right? Otherwise, they will move, right? They will fall down. Third one, the three forces should be coplanar. Yes, they should be on the same plane, right? Fourth one, the lines of action of the three forces should meet at the same point, right? It is regarding with this one, right? The line of action of the three forces, right, should be at the same point, right? But for the parallel one, right, we can't say, but this one, it is correct, right? So the first answer is wrong, Pute, right? First sentence or the first answer is wrong. Look at the seventh one. Which following quantity is a vector? This is a question from another year, right? Most probably I have get the questions. First we get the questions from the first 10 part, right? First 10 of 2016, first 10 of 17, like that, because I want to emphasize you how they arrange the questions. Here that most probably the first question is from 2016 and this is uh, maybe from 17, right? Again the same question, Pute. Which following quantity is a vector, right? Displacement, I told you they can give these things, right? Displacement is there, and again distance, pressure and work, right? So what is the vector one is displacement, right? Displacement. Look at the question 8. The unit of momentum is, the unit of momentum, how we calculate the momentum? Momentum we get, what is the question number 8, right? Momentum P equals m into v. Here m means the mass of the object and v means the velocity, right? Meters per second, right? Kilogram meters per second. Kilogram meters per second. The first answer. Kilogram meters per second. First one, put it. Right? Question number 9. Heat is transmitted from the sun to the earth by, what is the method? That is radiation. Radiation. Right? We know that there are 3 methods of transferring heat. Right? In grade 11, you learn those things. Right? There are 3 methods of transferring heat, right? What are the 3 methods? Conduction, convection and radiation, right? You have to remember the definitions and the examples and how it happens, right? So here the solar energy or the heat from the sun comes to the earth by the method radiation, right? Right. Then question number 10, right? We will see it. Right, here you are given a displacement time graph. Right, Pute? Displacement time graph. Right? Here, the first part, that means from 0 to T1, look at the graph, Pute. 0 to T1, there's a linear graph in this way. Right? Linear graph. Right? Up to T1. Right? Then up to T2, right? Up to T2 here. Right, up to T2, right, you are given a curved graph like this, right? It is continuous, curved graph like this, and it remains constant, right? So this is the graph that you are given, Pute, right? So here you are given a displacement time graph, right? Displacement time graph, right? So can you remember, right, by the gradient of the displacement time graph? Yes, what we can get by the gradient of a displacement time graph. Yes, can you remember what is gradient? That as you know, the difference of the x coordinates, we divide by the difference of the y coordinates, right? But actually, right, when you learn the maths or physics in A levels or in higher studies, right, that is the tan value of the angle that is formed with the x-axis, right? That is the proper definition. But for O level, right, I think that you learn from this grade 9, right, the difference of the x coordinates, you divide by the difference of the y coordinates to find the gradient, right? It is okay, you can remember in that way, right? So by the gradient of the displacement time graph, Pute, right, what we calculate? Displacement time graph. Using a displacement time graph, right, by calculating the gradient, we take the velocity, right? We find the velocity, right? We find the velocity, right? By using the gradient of the displacement time graph. So here, in this first duration, Pute, right, up to T1, look at here, we have a linear graph, right? We have a linear graph. So when we get the difference of this one, when we consider this one, and when we consider this one, Pute, right, as the gradient, we get the same value. We get the same value because this is a linear graph, right? If we get the same value for the gradient, right, by the gradient, it represents the velocity, right? So that means the velocity is same, right? That means the velocity is not changing. How we name it? We give a special term for that, that is uniform velocity. If we get the same value for the velocity, right? If we get the same value for the velocity, we name it as uniform velocity, right? So here, up to T1, Pute, up to T1, the gradient is constant. That means the gradient does not change. We get the same value for the gradient. That means the velocity is constant, right? So up to T1, it is a uniform velocity, right? It is a uniform velocity. Then look at the next part, Pute. T1 to T2, right? T1 to T2, what happens to the graph, right? With the time, the graph curved in this way, right? So when we get the gradient, look at the time, the gap between two y values, right? It reduced, right? Here, the difference of the y values, right? It reduced, right? So that means the velocity decreases. Velocity decreases. If the gradient decreases, that means the velocity also decreases, right? So if the velocity decreases, we give a special term for that. It is retardation, right? Retardation, or we say the deceleration, right? Deceleration or the retardation. You have to remember both. So from T1 to T2, it is a deceleration or retardation. Then what is the answer, Pute? Second one, uniform velocity, right? And retardation. Uniform velocity and retardation, right? And I have to mention one thing here, Pute, right? This is a curve graph. From T1 to T2, right? They have given a curve graph. Normally, we do not learn about the curved graph in O levels. But look at the textbook, Pute. Only one sentence is given. If the graph is curved, or if the velocity or the acceleration or the deceleration is not uniform, you are get a curved graph, right? Normally, for O level, we learn about uniform accelerations and uniform decelerations, right? But if the acceleration or the deceleration is not uniform, right, you are getting a curved graph. You have to remember that one, right? And for the curved graph, right, we get two shapes in this way and this way, right? Here like here, right? This graph, this shape of this graph, as we are given in the question, right? There what happens? The y value reduces. The y value reduces, right? So if the graph is like this, that means it is a deceleration, right? If the graph is like this, Pute, right? It increase the gap of the y values. It increase the gap of the y values. That means the gradient. Normally the time is going, right? So when we represent the acceleration, not uniform acceleration, right? Acceleration, you are getting a curve graph in this way, right? You have to remember these two shapes, Pute, right? Whether we do not have curve graph because of that sentence that they have given, right? They can give these things, right? Not to do the calculations, but to identify what is this, right? So here also, if the velocity decreases in this way, if something is decreases, you are getting the graph in this way. If the quantity is increasing, you are getting the graph in this way, right? So you have to remember these two shapes, Pute, regarding the graphs in the motion, right? So what is the answer here is the second one, right? Right. Then question number 11, right? Again about the units, right? Look at 11, Pute. What is the unit of the amount of work? Amount of work. How we calculate the work done? Yes, work done force into the distance that travel the object, right? Force means newtons, right? Newtons. We measure the force in newtons. Work done. Work done. Force into distance, right? Force into distance. Then force we measured by the newtons and the distance in meters, right? Here the answers are not given with the unit newtons, then we have to take the fundamental one, right? The newtons means kg ms minus 2 into meters, right? Then we have to simplify this one. Kilogram, meters and meters, that means square meters per square second. Per square seconds. What is the answer? Fourth one, Pute. Right? Fourth one. Look at that. Same questions are repeating, right? 12. Which of the following quantity increases uniformly? Right? Uniformly in an object moving with a constant acceleration. Constant acceleration. Which is increases uniformly if there is a constant acceleration, right? If the acceleration is constant, that means velocity is increasing. If the velocity is increasing, we say that is an acceleration, right? If the velocity is decreasing, we name that motion as a what? Retardation or deceleration, right? So what is the answer here is Pute, velocity. The unit of pressure, we discussed that one. Question number 13, unit of pressure. Pressure equals force divided by area. Force divided by area. Force by newtons and the area by square meters, right? Then what is the unit, Pute? Newtons per square meters. Newtons per square meters. Second answer, right? Second answer. Right, look at this one. 14. On a certain day in Norelia town, right? The daytime temperature was 16 degrees of Celsius and the nighttime temperature was 4 degrees of Celsius, right? The daytime temperature and the nighttime temperature is given, Pute, right? What is the temperature difference between the day and the night in Norelia town on that day in Kelvin, right? We have to find the difference, Pute. right? The difference means, right, the gap between two values, right? If it is in Celsius or if it is in Fahrenheit or if it is in Kelvin, the gap is same, right? So here the two values are 16 and 4. So what is the gap between 16 and 4? That means the difference. The difference is 12, Pute, right? There's a 12 gap between 16 and 4, right? But the 12 is in Celsius, right? We have asked the question in Kelvin. Then we have to convert, yes. Then we have to convert it into Kelvin. Yes, 12 means in the gap is 12. What is the temperature difference? Yes, what is the temperature difference between day and, here you have not asked the temperature, Pute. Temperature difference you have asked, right? If you have a doubt, right, because it has asked, yes, it has asked in Kelvin, right? We will check, right? You know how we convert the Celsius into Kelvin, Pute. Yes, how we convert Celsius into Kelvin. Celsius into Kelvin. Yes, how we can convert. Yes, what we have to do when converting Celsius into Kelvin, we have to add how many? Yes, when we convert Celsius into Kelvin, we add, yes, 273. If we are given the Celsius value, for that one, we add 273. Then we get the Kelvin value, right? So according to this one, during daytime, it is 16, right? Then we convert this Celsius value into Kelvin, right? Then we will see, right? Then what is the value? Put here 9, 8, 2. This is in Kelvin, right? Then the other value is 4 during night time. That one also we convert into Kelvin. We will see, right? 772 again in Kelvin. Now get the difference. 9 minus 7, 2. 8 minus 7, 1, 2, 2, 0. Then this is the difference, Pute, right? Here also same. 16 and the other value is 4. There also difference is 12. Right? We have not asked the values, only the difference. Difference means if it is in Celsius or if it is in Kelvin, the difference is same. Right? If you have asked the temperature in daytime or temperature in night time, then we can get these two values by adding these 273, right? But the question here is, Pute, what is the difference, right? Then if it is in Celsius or if it is in Kelvin, if we get the Fahrenheit values also, we get the same difference, that is 12, right? So the answer is the first one, right? Then 15. What is the pressure exerted by water at a point located 2 meters vertically below the water level in a lake? Very easy, right? How we calculate the pressure at a point in a liquid, right, from the water surface? What is the equation we use here? P equals, yes, H rho G. H means the height, that is 2. It has given the density is 1000 into gravitational acceleration 10. 20,000 Pascal. Or we can get as newtons per square meters. That is the value, Pute. What is the answer? Fourth one. Fourth one. Right? Then we will move to the 16. You are given a diagram like this. There's a block as A. It is partially immersed in water and floats, or half immersed and floats, right? not totally immersed or not fully immersed or not totally float. It is halfly immersed or partially immersed and float. Right? We will see. When a block of wood A is placed in the liquid, it floats with a part immersed, right? Partially immersed. Which of the following is the true statement? True statement in relation to this, right? We will see. The upthrust, right? The upthrust exerted by the liquid on A is equal to the total weight of A. Right here, according to the diagram, the block A is in the equilibrium position. Right? If any object is in the equilibrium position, the forces that are acting on that object should be equal in magnitude and opposite in direction. Right? So if this one floats, partially immersed and floats, we know the weight exert downward. Weight is there, no? If it is on a table or floats on water, anywhere, the weight exert downwards, right? And it is immersed in water, right? So the upthrust is acting on the object. Can you remember what is upthrust, Pute? Yes, when an object is fully or partially immersed in a liquid or a fluid, the upward force, right? The upward force that exerted by the liquid on the object, right? Exerted by the liquid on the object is upthrust, right? So here also there should be an upthrust, right? It exert by the liquid on the object, by the liquid on the object, and it is an upward force, right? So here the upthrust acting upwards, right? If the object is in the equilibrium position like this, what should be fulfill? The W or the weight should be equals to the upthrust, right? Otherwise, it cannot maintain the equilibrium position like this, right? So here, the upthrust exerted by the liquid on A is equal to the total weight of A. Yes, that is correct, Pute, right? So the answer should be the first one. We will check the others, right? The weight of the liquid displaced by A is equal to the weight of the part of A immersed in the liquid. No, we can't say like that, right? The weight of the liquid displaced by A is equal to the upthrust. That is correct, but it is not equal to the part that immersed in the liquid. We can't say like that, right? So the second one is wrong. The volume of the liquid displaced by A is equal to the total volume of A. No, that is also wrong. The volume of liquid displaced by A is equal to the, not to the total volume, no. That is to the volume that immerse, right? So the third one also wrong. The density of A is equal to the density of the liquid. No, it is halfly immersed and float, right? So we can't say like that. So the answer should be the first one, Pute, right? First one. Now we will move to the 17. Again, you are given a graph. Right? And if when you are given these statement like questions, Pute, right? As I am always telling, right, you have to be very careful. Right? You have to be very careful when you select the answers, right? Question number 17, you are given a graph like this. It is a velocity time graph. Velocity time graph. 10, 20, 25. Right? And here 10, 0. Right? This is the graph, Pute. Right? We will see. So, select the correct statement, right? The retardation of the object is 2 meters per square seconds. We will see. Retardation means this part, because this is a velocity time graph, right? This is a velocity time graph. So this is an uniform acceleration. This is constant velocity or uniform velocity, and this is retardation or the deceleration. Then we have to calculate the deceleration here. By using the gradient or by using the equation, we can find. Right here, in this part, the retardation. The change of velocity divided by the time. Change of velocity, final velocity 0, initial velocity 10. Change of velocity, right? Divide by time, right? I take as 1, right? 5 seconds. Then minus 10 divided by 5 ms minus 2. So they have asked retardation. So that should be a positive value, right? 2 ms minus 2. Yes, the answer is correct. The retardation of the object is 2 meters per square seconds, right? We will check the other answers also. The displacement of the object is 0. Displacement of the object is 0. No, Pute. Here, this is a velocity time graph, right? How we calculate the displacement by using a velocity time graph? Yes, by using a velocity time graph, how we can calculate the distance traveled or the displacement? Yes, we get the area that covered by the graph, right? We get the area that covered by the graph. Graph means this one, Pute. This part, and this part, right? So it is not 0, right? It is not 0. Then third one, because this is a velocity time graph, not a displacement time graph, right? Don't mix up these things. When you are given a graph, first check the two axes, right? Third one, the acceleration of the object is 10 meters per square second. We will see acceleration means this part, right? This part, no? Right? Acceleration means again the change of velocity. Change of velocity. The final velocity 10 minus initial velocity 0. Velocity ms minus 1 divide by the time, that is 10 seconds. 10 seconds. Then 10 divided by 10, that means 1 meters per square second. That is not 10, Pute, that is 1. Right? So the third answer is wrong. Look at the fourth one. The object has moved 20 seconds at a velocity of 10 meters per second. No, not 20 seconds, up to 20 seconds. That is correct. Not 20 seconds, here only 10 seconds, Pute. Right? It travels with the 10 meters per second velocity for 10 seconds, not for 20 seconds. So the fourth one also wrong. Then what is the correct one is the first answer. Right? First answer. Right? Then some questions from the electricity part or the Ohm's law and the resistance, the equivalent resistance. Right? What is the question here? There are 3 wires of equal length with uniform resistance. Right? There are 3 wires, equal length, uniform resistance. Illustrated below are 3 instances in which the 3 wires are connected between the points X and Y in the same circuit, where the first wire is connected as it is, right, as a single wire. The second wire is cut into 2 equal parts and the third cut into 3 equal parts. Assume the voltage of battery stay constant for the 3 instances. Then what is the question here is, the bulb connected to the circuit lights brightest in, right? We have to find which bulb lights up with a higher brightness. If the brightness is high, that means the current flows through the circuit also high, right? If the current is high, here you are given the voltage is same constant. That means the resistance should be low, right? To give a higher brightness, the resistance should be minimum. Then we have to find what is that one, right? So if we consider the three instances, in the first one, right, I'm draw only the resistance part put there, right? This is one. In the second one, it has cut into two equal halves, no, in this way, right? And in the third one, three equal halves, parts, right? This way put there, right? So if I consider the resistance of the total wire is 6R, right? Here I am using this, that is easy for the calculations, right? 6R, right? So in the first instance, the resistance is, right, 6R, or we can say 6, right? If it is 6R, right? So here in the second one, this 6R length cut into two parts, no, right? Then one is 3R and the other one also 3R, and they are connected in parallel way, right? Then we have to calculate the equivalent resistance, right? Equivalence resistance, right? So here 1 upon 3R plus 1 upon 3R, right? Then 3R, 2, and we have to get, this is 1 over R, no, right? Then R means 3R divided by 2, right? 3R divided by 2. Then when we consider this one, this 6R divides into 3 parts. Then one part is 2R, no, right? 2R, 2R and 2R, right? And they are connected in parallel way, right? So there also we have to get the equivalent resistance for there, right? That means 1 over 2R plus 1 over 2R plus 1 over 2R, right? Then we get the sum. Here 3, that is 1 upon R, then R should be 2 divided by 3R, right? 2 divided by 3R. Then look at which one has the least resistance, right? To get a higher brightness, right? To get a higher brightness, the resistance should be the minimum value. Then instance 1, that is 6R, in 2, that is 1 upon 2R, in 3, 2 upon 3R. Then what is the answer, Pute? Instance 3, right? Instance 3 has the least resistance, so it gives the higher brightness. What is the answer? Third one. Answer third one. Right? Then we will move to the question number 19. What is the ray diagram which illustrates the phenomenon of total internal reflection? Total internal reflection. Yes. What is the answer, Pute? Yes. Second one. In the first one, the two angles are same, theta and theta. So that is reflection. Right? Reflection happens through when the light falls on the surface, right? It come back to the same medium, right? But here there are two mediums, right? It, when we consider it as a surface, right, that is reflection. Look at the third one. What happens there? The angle has named as C. What is that, Pute? When we increase the angle of incidence, right, in one instance, right, in one instance, the refracted ray goes through the surfaces or goes through the intersurface, right? In that instance, the angle of incidence we name as the critical angle. We name as the critical angle and we use the letter C, right? So in the third one, you are given that instance, that is critical angle incidence, right? In the fourth one, the light ray goes to the next medium air, that is refraction. So the second one is shows the total internal reflection. How it happens here is when the angle of incidence is greater than the critical angle, right? When the angle of incidence is greater than the critical angle, the refracted ray again comes to the same medium. Total internal reflection, right? Total internal reflection occurs. So the answer should be the second one, Pute. Second one, right? Then question number 20. Right, so when we consider the questions like this one, Pute, right, we can't do at once for the exam, right? That is why I told you we have to practice these things, and for the then for the exam it becomes very easy, right? So we have to do more and more questions regarding all the topics, right? Yeah. Look at a jackfruit of mass 10 kilogram is falling freely from a height of 5 meters of a jack tree. What is the velocity acquired by the fruit when it touches the ground? Acceleration is given and assume that the resistance of air is negligible, right? Yes. When the jackfruit is in the tree, it has a what? It has a energy, that is potential energy. When it falls down, that potential energy converts to what? Kinetic energy, right? And according to the what? The law of energy conservation, we know no destroy of energies, right? There is no destroy of energies, only one type of energy converts to another type. So here what happens? The total potential energy of the jackfruit converts to what? Kinetic energy, right? And we can find the maximum kinetic energy when it touches the ground, touch the ground. The total amount of potential energy when it has on the tree, in the tree, right, converts to the kinetic energy, the maximum amount of kinetic energy when it touches the ground. So we have to equal these two, right? Question number 20. Potential energy, how we calculate? mgh, and kinetic energy half mv squared. What we have to find is the velocity when it touches the ground, right? So m to m cancel, right? We have to find v, no, right? Then we take these two to this side. Then v squared equals 2gh. You have to remember these things, Pute, right? Then v means square root of this one, 2gh, right? 2gh. It is very easy to remember this one. Then v equals 2 into g means 10 into the h is given 5. Square root of this one. Yes. 50 into 2, that means 100. The square root of 100, that means v equals 10 ms minus 1, 10 meters per second. Right? So the data for the mass is, yes, not valuable. If they are given the mass, no need of substituting the value for mass, Pute, the same object. So no need to give the values. We can cancel this and take what we want. Right? So the answer should be the second one, 10 ms minus 1. Right? Again, you are given a question from the equivalent resistance. We will see, right? Right, 21 Pute. A few ways of connecting four resistors of equal magnitude, right? The resistance is same, equal magnitude are shown. Of them, which one has the lowest equivalent resistance? Lowest one, Pute. Right, lowest one. Right. If we consider the resistance is R this way, right? In the second one is here and the other two with parallel connection, and again the fourth one in this way, right? Third one here, and the other three connected in parallel. Fourth one, all the four resistors connected parallelly, right? So all are R Pute, right? Don't get the values when you do these things, right? It is very easy when you use the symbols, right? So these are the four. We have to find which one has the lowest equivalent resistance. So in the first one, our 4R resistors are connected in series manner, right? So we have to get the sum. Then what is it? That is 4R. 4R, right? So here Pute, one R is there and another R is there, right? And two resistors connected together. We know when it connected resistors in parallel way in the same resistance, right? They have the same resistance and they are connected parallelly, right? They are connected parallelly. When we get the equivalent resistance, right, there's a simple way that we can do. We have to divide the resistance of one resistor by the number of resistors, right? The resistance of one resistor, we have to divide by the number of resistors. We do this one if the resistance is equal only, right? So then here, when we get the equivalent resistance, right? So instead of these two, we get this one, right? This is half, no? Then 1, 1. That means 2.5, right? The equivalent resistance is 2.5 R, right? Then look at the third one, Pute. Here there are 3. That means very easily we can say R divided by 3, right? R divided by 3. Then 1 and 1 upon 3, right? When we get the equivalent resistance, right? Then look at the fourth one. There are 4 resistors with R resistance. Then when we get the equivalent resistance, right? R divided by 4. R divided by 4. That means half R, not quarter R, not half Pute, quarter R. So it has the, yes, it has the lowest equivalent resistance. Lowest equivalent resistance. So the answer should be the fourth one, right? Right here, and there is another thing that Pute, it is a small trick that we can use, like this one, right? In this one, I told you when it use more resistors, several resistors parallelly, if they have the same resistance, when we get the equivalent resistance, we have to divide the resistance of one resistor by the number of resistors, right? To get the equivalent resistance. Resistance of one resistor, we divide by the number of resistors to get the equivalent, right? There is another thing, Pute, right? When we use more resistors in parallel, whether they have the same resistance or not, right? Same resistance or not. The thing is, when we use more resistors in parallel, right? When we get the equivalent resistance, it should lower than the lowest resistor, right? The equivalent resistance is less than the resistance of the lowest resistor, right? Think like this. If the resistance are in this way, 6 ohm, 4 ohm, 5 ohm, 3 ohm, right? If these are the resistance values, when we get the equivalent resistance, the least one is 3 ohm, no? Right? So the equivalent resistance is less than 3 ohm, The equivalent resistance is less than the lowest resistance of the resistor when they are connected parallelly. Right? So you have to remember that one also when you are calculating the equivalent resistance in parallel connection, right? You have to get the value for the equivalent resistance, a lowest value or a less value than the lowest resistance. Then you can check whether your answer is correct or wrong. Right? Then 22. Question number 22. Again about the resistance. Right? 22 Pute. Right? There also you are given ABC 3 circuits. Right? The bulb is there. Right? This is A. In B, other than these two, there's a resistance also. Right? In C, the dry cell is there and the bulb also there. Right? And these 2 points are connected with the conductor or the wire. Right? Then what is the question is, in which order does the brightness of the bulb decreases in the circuits ABC? Decreases. That means first we have to find which one has the highest brightness. No, decrease arrangement. No, highest brightness and the lowest one. Right? We will see, Pute. Right? So here, when we consider the A and B, Pute, A and B, the same dry cell, same bulb. But here, when we compare these two, right, in B, there's a resistor, right? So, due to this resistor, the current decreases, right? So, the brightness also decreases. But here, there is no resistor, right? The total amount of current goes through the bulb. But here there's a resistor, so the current decreases, so the brightness decreases. So when we consider these two, when we compare these two, A is more brighter than B. A is more brighter than B, right? A is more brighter than B. When we compare these two, right, then we will see. Right? In the C1, Pute, in the C, right, these 2 points connected by a wire, right? So here, along this wire, the resistance is 0, right? The resistance is 0. So that what happens when the current flows from here, right? The current flows from here, there are two paths to go, right? When it goes through the bulb means there is a resistance. But when it goes through this one, there is no resistance, right? So the current flows from here and here, right? So no current flows through the bulb. No current flows through the bulb. Then what happens? It has the lowest brightness. It has the lowest brightness. Lowest brightness. Decrease, no? Decreasing. A has the highest brightness, then B, and then C. Then what is the answer, Pute? First one, right? We say arranging the circuit in this way, that is the short circuit, right? A short circuit of a electrical system, right? So when we connect the 2 points by a conductor or a wire in this way, the resistance becomes 0. So the total amount of current goes through that path, right? So the answer should be the first one, Pute, right? First one. Right? Then 23. Question number 23. That is a question from grade 11 section, Pute, that waves lesson. Never mind, we will see. Right? This is a question from the last year one, right? Consider the following statements given about mechanical waves. Mechanical waves. Right? 3 statements are given, Pute, right? 3 statements are given. The frequency of the wave changes on entering from one medium to another, right? Frequency. What is frequency? Frequency means the number of oscillations that occur in a unit time, Pute, right? So that depends on the sound source, right? According to the way according to the sound that produced by the source, the frequency depends on that. Only the frequency depends on the sound source, right? It does not change when entering from one medium to another like that. So the statement A is wrong, right? Frequency of a wave, right, does not change, Pute, right? B, the speed of the wave does not depends on its frequency. The speed of the wave does not depend on frequency. Yes, that is correct, right? The speed does not depend on the frequency, Pute, right? See, the speed of the wave depends on the medium through which it travels. The speed depends. Yes, that is correct. According to the density of the medium, the speed changes, right? So, the speed depends on the medium that it travels. So, the statement C also right. Right? So, the true statements are B and C. Only B and C. Fourth answer, Buddhi. Fourth answer. Right? Then 24. Right? 24. What is the advantage of using the handle fixed to a door in the occasions of opening and closing it? Opening and closing it. What is the advantage of using the handle? Right? When we open or close the door, right, using the handle, how it is important. Yes, what happens there? When we use the handle, we have to apply only a small force, right? Small force. What is the answer? Applying a small force. Third one, Puti, right? Third one. 25. Get that? It is from the, again from the grade 11 section, right? Grade 11 one, right? Never mind, I will say the answer. The first one, right? Vp divided by Vs, right? Voltage of the primary coil divided by the voltage of the secondary coil equals the current of the primary coil divided by the current of the secondary coil. We have to find the answer for the current of the secondary coil, right? That should be 0.2 amperes. First answer, right? When we move to the grade 11, we will discuss these things, right? First answer, right? Again, you are given a graph, Pute, right? Look at that one. Question number 26. The graph is like this. This part, no. Up to here, we have to find Pute. 20 and 10 here, 0. Right? What is the question here is, what is the displacement of the object from beginning to 20 seconds? That means up to here, right? This is the velocity time graph. So how we get the displacement? By getting the area that covered by the graph. So what is this shape? That is a trapezium shape. So we have to get the addition of the two parallel sides, right? Then 20 plus 10, we divide it by 2 and we have to multiply by the perpendicular height. Yes, what is the answer, Pute? 150 meters. 150 meters, right? When you are doing these questions regarding graphs, consider about the two axes, right? It is very important. And for the structured or the essay paper also, if you are given a graph, first look at it very carefully, right? And the units that they have given. Right, 27. Which of the following phenomena agrees with the Newton's third law of motion? Newton's third law of motion. What is Newton's third law, Pute? Every action has a reaction. Every action has a reaction. So what is the statement regarding that one? A ball falling down from a higher level, bouncing after touching the ground. Bouncing after touching the ground. So it is regarded with the Newton's third law. Right? Read the other things. They are not regarding with the Newton's third law. Right? Question number 28, Pute. That is from the heat lesson. Never mind, right? As shown in the figure, the glass Q stick inside the glass P. Right? Which of the following strategies is suitable to separate the two glasses easily? There, what happens? The expansion and contraction we have to apply. Right? The glass Q is stick inside P. So, to separate these two, we have to contract Q and expand P. Contract Q and expand P. So, to expand P, it should touch with hot water, right? And to contract Q, it should touch with cold water. So, in Q, there should be cold water and P should be in hot water. What is the answer, Bute? Second one, right? When touching with hot water, P get expand, right? When touching with cold water, Q get contract. And very easily, we can separate the two glasses out, right? Then 29. The limiting frictional force between two objects with rough surfaces in contact depends on. The limiting frictional force depends on two factors, Pute. Two factors. What are the two factors? The normal reaction and the nature of this contact surface. Nature of the contact surface and the normal reaction. And the area of the contact surface does not affect to the frictional force. Does not affect to the frictional force. Then look at the first one. The area of the contact surfaces. No, Pute, that is wrong. Second one, the normal reaction and the nature of the contact surfaces. Yes, that is the answer. Normal reaction and the nature of the contact surfaces, not the surface area of the contact surfaces. In the other two answers, right? The area is given, so we can cut those two. And here that I have to mention another thing, Pute. When this is we have to apply this one in the first paper one, right? If you are given the four answers, right? Here the question is about the limiting frictional force and the factors, right? So to do this one, you have to uh, you should have the theory well, right? You have to know all the theory parts to do this one, right, Pute? So when we consider the limiting frictional force, we know what are the two factors affect to the limiting frictional force, right? What are the two factors? Yes, the normal reaction and the nature of the contact surfaces, right? The normal reaction and the nature of the contact surfaces, those are the two factors affect to the frictional force, Pute, right? And there is one factor that does not affect to the frictional force, that is the area of the contact surfaces. We definitely know that the area of the contact surfaces does not affect to the limiting frictional force. So here there are three answers with that one. First one, area of the contact surfaces. Third one, area of the contact surfaces. And fourth one, area of the contact surfaces. Right, Pute? So very easily we can cut 1, 3 and 4. 1, 3 and 4. The answer should be the second one. So that neglecting method is very important. That if you do not have time for the last few questions, you can apply this one. But for that one, you should have the good memory about the whole subject content, right? If you are given the four answers, right? If you are given the four answers, there are some answers that directly we know, no, that is wrong, right? So very easily we can cut those, right? So if there are two answers, then 50-50 chance is there, right? So do the calculation or get the memory, get the theory only for these two, right? Like that, the neglecting method is very important. You can save time, right? And if you have a very limited time for the last few questions, you can apply this method, right? But to do this one, Pute, you should have a good memory about the whole subject content, right? Otherwise, you can't cut, right? To cut the answers or to neglect the answers, definitely you should know, no, that is wrong, right? So for that one, you should have a good memory about the subject content. So it is very important, right? Look at the question number 30, Pute. The gravitational acceleration on the moon, right? On the moon is 1/6 part of the Earth. If the gravitational acceleration on the Earth is 10 ms minus 2, what would be the weight of an astronaut of mass 10 kg on the moon, right? 10 kg on the moon, right? We have to find the weight, no? What would be the weight here? We know how we can calculate the weight. Yes. W equals mg. G means the gravitational acceleration, right? So the mass is given 10. Here G is 10, right? But in moon it is 1/6 part of 10, right? Then get the answer. Very easy. Yes, that is 100 newtons in the on the moon. Yes. Third answer, Pute. Right? Third answer. Right? I think that that is enough for today, because for the next 10, when we move up to 40, there are many things to discuss, Pute. Right? So we will postpone it to the next day, and I will send some other questions from the physics part, right? Go through that and complete those also. Then we will discuss the rest of this one on next Sunday, and the other paper that I will send, right? Okay, then I think that is enough for today. Shall we wind up the lesson, Pute, right? Good night, all of you.